Good morning, everyone. We have 9 o'clock, so it's time to start. So as a first thing, please let me know over the WhatsApp chat that you can hear me and see me well. And then we will start the presentation. Okay, I believe we have enough confirmations that everything is fine with the connection. You have stable quality and everything. Just in case that there is some kind of issues with the connection or quality of the video on your site, please make sure that in the YouTube application you set the full HD resolution, or you change the connection that you have on your side. Maybe this is the issue. So here is our presentation, and as I mentioned over the WhatsApp chat already, today we will focus on the Mythic 18 and Mythic 3CRP. So those are 3D instruments which we currently offer in our company. So let's start with the basic information and introduction to the team. Here you have the email address to all of the engineers which are currently in the Cormay Diagnostic Support team. So here is support@orphymedical.com, and there is also support@cormay.com if you want to send or request some kind of information about the Cormay products. And of course, the Orphy Medical is about the Orphy products, about the hematology. So who is in the group right now? I mean, who is the engineer or the department? As a first person on the list, there is a director, Michel Legrand. So he's sitting in the office, which is in Geneva, in Switzerland. The next guy is Jan Staniak, Michał Szubartowski, Maciej Greszta, this is my name. And there is also a new engineer, Łukasz Szymański. Some of you may know him because previously he was supporting some biochemistry products, but right now he started to work with us. Previously, he was working in the domestic service for the domestic service team of the Cormay Diagnostic. Other contacts at Orphy. So here you will find the email address to the QC department manager and specialist who is responsible for your request regarding the quality of the reagents, calibrators, QC. So when you will use the support at Orphy Medical, you can use this email if you have technical questions regarding the technical problems related to the analyzer. But if you have issues related to, let's say, contamination of the reagent or the damage to the reagents, QC or calibrators, you can directly contact Michał or Maria. Other contacts are customer service department. So right now there is a Victoria Kostadinov, and she's a manager there. And basically for each country, we have a dedicated person who is responsible for this country or the region where your country is. So most likely your company already know who to contact, but just in case that you don't know what is your exact contact, you can always send an email to Victoria. So this is agenda for this day. So we will start with the introduction. Later we will talk about the 3D technology, and we'll also focus on the Mythic 3CRP. I believe we will spend most of the day today on the 3CRP topic, and tomorrow we will talk more about the Mythic 18. So for some of you, Mythic 18 is already well-known products, and actually this Mythic 18 is with us for many years. This was the first product which was introduced by the Orphe to the market. So a lot of people already know this product. And as I said, we will spend more time on Mythic 18 tomorrow, but today we will focus mostly on 3CRP. I want to make full training of the 3CRP first, and tomorrow, as I said, Mythic 18. So here is the our current portfolio of the analyzers. So what we are seeing Mythic 18, 22OT. Mythic 18 is a 3D device, 22OT is a 5D device. This is also 22AL. This is also 5D device. Mythic 60 is a replacement for Mythic 22OT, 5D device in this case. Mythic 18 VET is a veterinary version of this small analyzer. So this is also 3D device, but instead of using reagent containers, is using reagent bag, which is sitting basically inside of this reagent compartment. We also have 5D veterinary products, but this is a topic for a different training. On this slide, you will see Mythic 3CRP and Mythic 70. So Mythic 70 is a replacement for 22AL, because this is basically Mythic 60 with the autoloader. So it's a 5D device with the autoloader. 3CRP is basically an addition to our portfolio. This is not a replacement to Mythic 18. Basically, this is additional analyzer which we have in our offer, and this analyzer contains also the CRP module. So you have the full spectrum of 3D results plus CRP, which can be measured by this device. And here on this slide, we are seeing also Mythic X. This is a potential replacement for the Mythic 18 for the future, but still, this device was not introduced to the market yet. But we are working on that, and maybe with the end of the year, we will introduce it. So this thing will be announced by the team. So stay tuned. Here is an introduction to Mythic 3CRP, and later we will talk about the 3D technology. So what we are seeing here, you can say that basically this analyzer is are two devices in one box, because it's contained the hematology module, which can give you the CBC and 3D results. But also we have a separate module which can give you the CRP results. So actually, in terms of results, analyzer can only measure CBC plus 3D. It can also show you the CRP results, or it can show you all those results at one run. So it's up to you how you want to program it. Later, when we will work on the software, you can take a look what are the modes of the operation for this analyzer. This analyzer also have a pre-dilution mode. So here we have some basic technical specification of this device. Here is a list of the parameters which are reported by the analyzer. And here you have the reagents. So we have diluent, lyse, and cleaner. So diluent is in the 10 or 20 liter bottle, lyse are in the smaller bottles, and those two reagents are only for hematology part, right? So it's a CBC and diff parameters. Cleaner is basically external cleaner. So this is hypochlorite solution. And underneath, we have reagents for CRP. So there is a CRP reagent and CRP lyse. So there is additional lyse sitting inside of the analyzer, and CRP reagent, which is also sitting inside. And actually, there is a inside of the analyzer there is a refrigerator. So since the CRP reagent need to sit in the lower temperature, so it's like between 3 and and 8 degrees, if I remember correctly. And actually, this refrigerator on board of the analyzer can work 24/7. So even if when the analyzer is turned off, this refrigerator can be active and reagent can stay on board, and they will be cooled by the device. So it's very similar to biochemistry approach, where you have the cooler on board of the biochemistry analyzer, and basically the principle for the CRP analysis is very similar to principle which is used in the biochemistry analyzers. Controls for this device. So, but for the hematology part, so we can have normal level controls in one box. So you will have like a box of 6 of those vials, or we have a box where you will find low, normal, and high, and this will have like a 2 vial of each level. Calibrator for hematology. 3CRP cal. Basically, for hematology, you can also use a normal mid-cal. I believe when we start this project, we register this thing with those names because we were not sure if our mid-cal or mid-3D can be used on this analyzer. But right now, we changed the approach, and mid-cal, which is basically our common calibrator, will be used on this device, and mid 3D also will be used on this device. So this specification need to be changed. And actually, I don't know if this is at this point we are in this at the time that we are changing the names and everything. So stay tuned, because maybe there will be some kind of information about those things. For the CRP controls and calibrators, we specify a list of those things, and we are not able to change anything. So basically what you are seeing on the screen is basically controls and calibrators which are used on this device. Sampling volume is 20 microliters, and those 20 microliters will be used for normal aspiration, and also in the pre-dilution mode. We are using the same volume of sample. And this is, by the way, this is whole blood. So even the CRP analysis is done on the whole blood, and the reason for CRP lyse is because of that, right? Because we are using whole blood. So first we need to lyse the red blood cells, dilute everything which is not needed, and then CRP reagents is used to basically combine antibodies which are on the latex with the CRP in the blood. Throughput, so CBC, 60 samples per hour, so CBC plus 3D. This is the meaning of that. For CRP, we have slightly less, so it's 45 if we also use the CBC, and CRP is a limitation here, so 45 if we only use the CRP. Sampling mode, this is only open vial. There is no autoloader, so basically you need to mix the blood and present the blood to the analyzer, and the operator need to do that and run the analysis. Maximum background count, so basically this is just information what will be the limit for the background count on this analyzer. In terms of carryover, here you also have the information. In terms of precision, here you have the information. Data storage, as you can see, is very big. So this can store 50,000 samples with alarms, with the histograms, with everything. The working temperature for this analyzer is between 18 to 30 degrees. What we have in terms of accessories, there is a barcode reader and the keyboard. And of course, you can connect also the USB printer, and also you can use the USB storage device to copy device to also upload the information about the controls and yeah, about the controls basically. Internal external printer. Yeah, there is a internal printer built-in, so it's like a small thermal printer built-in into the analyzer. In terms of linearity, we have the range between 0 and 300,000 for WBC. RBC is from 0 to 8.5 millions, or yeah, millions per microliter. It's really depends what are the units that you are using. Here we have from 0 to 300,000 per microliters. Here we have millions per microliter. For the hemoglobin is from 0 to 25 grams per deciliter. For PLT, we have from 0 to 4,000 platelets per microliter. In terms of dimensions, the device is bigger than Mythic 18, and basically the size is significantly bigger. And in terms of weight, it's also 2 times heavier. We have more modules inside. But it has like a quite big touch screen, so this can be advantage to some people. And actually, the graphic user interface is completely different than Mythic 18 graphic user. So here we have another slide, and on this slide we can also see a few of those information which were provided already on the previous slide. I was mentioning about the onboard refrigerator for CRP reagent. It's on that side. It's not visible from this angle, but later we will see it on some other slides. Easy management of the reagent with the RFID reagent card. Basically, underneath this cover, there is also RF marking here on the front panel, and underneath this cover we have the RFID reader, and all reagents are locked by the wireless cards. In the meantime, okay, someone is saying that audio is not coming, so let me just check what is wrong. Okay, it looks like that we are still live, so maybe it's an issue on your side. In case of any issues on your side, just refresh the web browser or just use the link one more time, because it's maybe maybe some kind of issue on your side. On my side, everything seems to be all right. I have a stable connection, so everything seems to be all right at this point. What was not mentioned in the previous slide, it's also one preventive maintenance per year. And automatic flashing. So automatic flashing, this should have a different name, but actually what it is, it's when analyzer will discover, when a device will discover that one of the aperture is clogged in the impedance channel, it will try automatically recover the device from that state. So this is the meaning of the automatic flashing, in my opinion, at least. Oh, by the way, on this slide we can see the card for diluent for this analyzer, and actually this is how it how the card is used to replace reagents. Technology. So device has 3CRP, Mythic 3CRP, has three uh, measurement chambers. Mythic 18 will only have the WBC BUT and RBC PLT BUT. The CRP BUT is not present in the Mythic 18. So what is happening in the WBC BUT? Basically we are measuring the total number of white blood cells, and also the device can differentiate between three types of white blood cells. So we are talking about the lymphocytes, mid-sized cells, and granulocytes. So we are using electrical impedance method. We also can measure the hemoglobin concentration, and as you know, the hemoglobin is from red blood cells, right? It's basically a compound which is chemically bonding the oxygen, and is responsible for transferring oxygen through the human body and also through the all animals' body, basically. Not only humans has it. So we are measuring the hemoglobin in the WBC bag, but hemoglobin is on the red blood cells. So actually, we will use something like lyse. Lyse is destroying red blood cells, and destroying red blood cells, and also is combining hemoglobin into some uh, chemical compounds, which later can be used, measured by colorimetric method. And actually, this is also something like biochemistry measurement methods. This is, I believe, it's like an endpoint reaction. So we are checking our background, or yeah, background. So background will be clear diluent in the chamber, and later after this this reaction appear, I mean, we destroy the red blood cells, and hemoglobin is already combined into some uh, compounds. We are checking what is the difference of the absorbance at this point, and basically the difference in absorbance is proportional to the concentration of the hemoglobin according to the device calibration. On the RBC PLT BUT, we are measuring the RBC PLT, and in this case, also the electrical impedance method is used. In the CRP chamber, device will measure the CRP concentration. So here is the name of the method. So it's latex enhanced scattering immunoturbidometry method. So this is the key name, scattering, right? So we are not measuring the light which is transmitted, but we are measuring the light which is scattered by the sample which is in this chamber. And later on some other uh, slides, we have more information about those things. So this is the reminder, basic information about the human blood. So what we have in blood, right? This is the whole, let's say, sample, and 50, 55, maybe 60% of this thing is plasma, and only less than 1% is leukocytes and platelets, and 45% of this thing is are red blood cells. So so keep in mind that the ratio between leukocytes and red blood cells is not equal. You can see it's like a there is a very big difference between white blood cells, PLTs, and red blood cells. And the reason for that is uh, this is how humans are made, right? So this is it. But keep in mind those ratio also. And also here on this slide, we are talking a little bit about the size difference. So in terms of white blood cells, we have few types of white blood cells, which are usually present in the blood. But here we have only one picture. But what is important for you? The size of those cells. So it's, let's say, between 6 and 10 micrometers in diameter. And also in terms of the number of those cells, we are between 4 and 11,000 per microliters. For red blood cells, on the other hand, the size is very similar to white blood cells. You're seeing it's let's say it's like a lymphocytes basically, because the lymphocytes are the smallest white blood cells. So it's 7.5 micrometers. But check this out. The number of those cells is like a 3 orders of magnitude higher than the number of white blood cells. So actually, when we want to make any measurements in the WBC channel, we need to destroy those red blood cells. And this is the action of the lyse reagent. Lyse reagent is dissolving basically the red blood cells. We don't want to see them in the WBC channel, because this will saturate the measurement, and the device will only see the red blood cells. It will not see any white blood cells because the number of those cells will be so big. And PLT number, as you can see, the size of those is smaller than size of the white blood cells. So actually, the number of PLTs is also significant, but since the size of those is smaller than size of the white blood cells, device can ignore PLTs, which will be still present in the WBC chamber. It will not take them under into consideration during the white blood cells measurement. RBC and PLT, they are only measured in the RBC PLT chamber. This WBCs are measured in the WBC chamber. And here on this slide, maybe you already know that, but just in case that this is not clear for you, device is making a series of dilutions. So first dilution is when the whole blood sample is put into the WBC chamber, and then device is adding, in the first step, is adding diluent into this chamber. So this diluent basically make a dilution in such a way that the number of particles in this solution is at such a level that the device will be able to correctly count them. By correct counting, I have in mind that each white blood cells will go through the aperture in such a way that the cells will not saturate the analyzer, right? So what I want to say is each cell will go through the um, uh, uh, through the aperture separately, roughly separately, right? So this is the reason for dilution. And at this point, if we want to make a count on the RBC parameters, as you can see, maybe the color can suggest you something. We can see that still there is a lot of red blood cells. Since we basically took like a 20 microliters of blood and diluted by, I don't know, some factor of 200 or something, still the number of red blood cells still is very high. So what we need to do for RBC analysis, we need to dilute the sample one more time. So this second dilution for RBC PLT is by the factor of few thousand, because analyzer is taking 20 microliters of pre-diluted blood from the first chamber, and then it's transferring it to the RBC chamber. And this is the second dilution for RBC PLT. When this blood is transferred from here, then analyzer is adding lyse into the WBC chamber to destroy red blood cells in this chamber. So because we only want to measure white blood cells, right? So the lyse is basically destroying red blood cells, is combining hemoglobin into some kind of chemical compounds, which later can be measured, because this is also the chamber where we are using this colorimetric method, right, to measure the hemoglobin concentration. And lyse has another action over also white blood cells. The lyse is preparing the membrane of the white blood cells in such a way that they will shrink just a little bit, and each population of the white blood cells will shrink in a slightly different manner. So they will have a slightly different size. And actually, this is the thing which allows us to differentiate between three populations or three types or three groups of the white blood cells. It's up to you how you want to call it, population types, groups. It's up to you. For the RBC PLT, we're only adding a diluent, but please keep in mind that this is series of dilution. So we diluted the sample twice, and actually the color can suggest you also something, right? So here is a 20 microliters in like a big volume of diluent, and later we are taking a little bit of this thing and we are going here, so you can see that color is even it's only barely present here, right? In the real life, in the analyzer, you will not see any color in the RBC PLT chamber, because the number of cells in this dilution is so low that it's allowing analyzer to make a measurements, but actually the color change is barely visible. I will say you will not see any color change, so you will think that there is only diluent in the chamber, but in reality it's different. We have the RBC and PLT in this chamber. Coulter principle. So this is the principle which is used to measure those cells. Uh, in and basically this is very basic, and it was introduced or discovered, I believe, in 60s. So it's very old. On the beginning, I believe this was from the beginning it was used to measure cells, but right now this principle is also used to to measure size of the particles in the electrolyte. It doesn't you don't need to count the cells. The only thing is that those particles should not conduct electricity, and then you can measure those. So those can be some plastic particles or different solid particles. But here in hematology analyzer, we are counting the cells. So when you consider the cells as a particle, you know that cell has a membrane, right? And on the surface of this membrane, we have the lipid layers. So one side of those one side of this layer is hydrophobic, and the other is basically hydrophilic. And what else is important here is that this lipid layer don't want to conduct any electricity, right? This is one of the properties of this lipid layer. So actually, you can consider those cells as small particles which are not conducting electricity. And since this Coulter principle is relying on the impedance change in this small region which we call the aperture, uh, this when the cell is passing through the aperture, we can detect such a change of impedance. So what is happening? On one side of the aperture, we have the chamber, right, where we are making dilution, and there is one electrode. On the other side of the aperture, right, the aperture is not conductive, is not conductive, so it will not conduct any electricity. Only uh, path for the current is through the liquid which is in the aperture, and aperture size is quite small. It's a small opening, small hole, uh, and on the other side we have a second electrode. So let's apply constant current across those 2 points. What we will have here, basically, when we will measure the voltage, we will have a voltage which is on the one level, because the size of the aperture is constant, right? And the current is also constant, right? So this whole circuit is not changing. And what will happen if we will apply vacuum on this side of the aperture? We will basically draw the liquid which is in the chamber with those particles through the aperture. And actually, when the cell is passing through the aperture, we are dispersing a little bit of liquid from this exact point or this exact passage through the aperture. So when we will disperse this liquid, we are also changing the impedance, local impedance of this position. So impedance is changing. current is constant. So what we will have? We will have change in voltage. So actually those voltage impulses are proportional in terms of size. They are proportional to the cell volume. And another information which is recorded by the analyzer during this measurement is also counting impulse. So actually, when the size of the particle is higher than some specific threshold, analyzer will consider this particle as a cell. Because, as I said, some particles like a PLTs in WBC channel are not counted. Device don't care about the PLTs in the WBC channel. So basically PLTs are below the thresholds which is considered as white blood cells. So PLTs are not even counted by the analyzer at this point. So keep in mind, two informations are recorded when the cell is passing through the aperture. We are recording the size of the cell or volume of the cell, right? So we can differentiate if this is lymphocytes, mid-sized cells, or granulocytes, right? Or in the PLT RBC channel, we can differentiate between platelets and red blood cells. We can even say how big are those platelets and how big are those RBCs, because later a device is building the histograms. And counting impulse. So we know what was the number of the particles which pass through the aperture. And actually, the device also knows the volume of liquid which was passing through the aperture. So we know the volume of liquid, we know the number of cells. So actually, this is also an information which can help us to determine what was the concentrations of the cells, right? So we will know that, for example, there was a 5,000 white blood cells per microliters, 4 million RBCs per microliters, etc. Right? So I hope you got the point. This is the diagram, exact diagram of the Mythic 3CRP. Basically, in terms of principle, the Mythic 18 use the same principle of measurement, but it's basically it's built in a slightly different way. But as I said, the principle is identical. Mythic 18 and 3CRP. So uh, they call it front tank electrode. Front tank. So this is basically the chamber where the dilution happens. So where the analyzer is making dilution. Here we have the basically our aperture or counting head. And here we are also saying what is the diameter of the aperture. And as you can see, the diameter is different for white blood cells and RBC. The reason for that is because device is measuring different size of particles in each chamber. So actually this size also matter here because this was made in such a way to give the analyzer the best possible signal in terms of electrical signal which are recorded. So the cells which are dispensed in the diluent are passing through the aperture and they are drawn by vacuum. There is also a rear electrode, right? The second part of the circuit. And you got the point. Analyzer is simply just counting the number of the cells and is counting and is measuring the size of each particles. And later um, some FPGA units. So those FPGA are specialized electronic components which are able to count the cells. So if we will take the oscilloscope and we will basically try to see what are the sizes of the particles which are passing through the aperture, we will see something like that, right? So it will be information about the size of the particle in time, right? So let's say we have some kind of femtoliters in on this scale and over time. And what analyzer is doing is counting the number of, let's say, each of this size, and it's simply just adding those on the histograms, right? So it's basically, here is a different relation. It's a relation between size and the number of counts. So those are the histograms. And actually, here we have the WBC histogram. So here, first peak is a lymphocytes. Later, we have mid-sized cells somewhere in the middle, and everything here are the granulocytes. Right? So here we will have lymphocytes. Here we will have mostly monocytes, and later everything start to become mixed. So here on the beginning you will still see some monocytes, but we also have here the basophiles, eosinophiles, and neutrophiles in this population. So 3D analyzer is not able to differentiate between more types of the white blood cells, only three population types, groups, as I said. It's wherever you call it, wherever is working for you can be used here. For the RBC parameter, device is doing the same thing. Is recording all those signals, and later the algorithms in the FPGA units, they are building those histograms. So what we are seeing here, the RBC parameters can give us some extra information about the red blood cells. So device is first information is device is counting the total number of red blood cells. For white blood cells, we also counting those things, and later, according to those information like here, device is basically dividing this whole histogram into three population. From RBC, we are counting the total number of red blood cells. Device is also can measure or find the MCV value, which is mean corpuscular volume of the red blood cells. So this is basically, usually it's a mean size of the red blood cells. Device can also count or calculate parameters like RDWSD and RDWCV, and those are basically the width of this distribution curve in two positions, like here and here. And according to those information and according to the hemoglobin concentration, other parameters can be reported by the analyzer. For PLT channel, we also count the total number of PLTs. Device can also see or calculate what is the MPV, which is the mean platelet volume. So it's a parameter similar to this thing, but it's basically about the PLTs. Device can also report to some parameters like PLCR, and PLCR are platelets bigger than 12 femtoliters. So everything on this side from roughly somewhere here, those will be the PLCR percentage. And there is also the MPV. So this is also the width of this histogram. And other parameters are basically calculated accordingly to the data which was recorded by the device. Colorimetric method. So this is the method which is used for hemoglobin. So as I said previously, we need to have two signals. One is a blank. So it's basically absorbance value of colorless diluent in the chamber. So this is usually obtained before the measurement appears. So it's basically colorless diluent. Analyzer is recording those data, and later we are also measuring what is the sample absorbance. Right, so red color sample solution in the chamber, and what kind of light will be absorbed by this hemoglobin? It's a green light, so 5 to 5 nanometer green light, as you can see on this semantic diagram. There is some kind of filter which is blocking different wavelengths because we are photo detector only want to see this lump, this green lump color. And as I said, you can set that the difference in absorbance is directly proportional to the hemoglobin concentration according to device calibration. And actually, this is nothing special. And all hematology analyzers currently will use the same principle. This is well-known thing, and same as culture principle. This is the thing which is used by everyone. CRP CRP measurement. So we have one additional chamber in the analyzer, and what we are using in this case, we are using a laser light, and this laser is a red laser for CRP. And as I said, we are not relying on transmitted light, we are relying on the scattered light. Right, so this is also very simple. We need to, first thing uh, we need to obtain what is the uh, let's say background level for this scattered light uh, on the beginning of the measurements before the sample is added, and later we are checking what is the basically scattered light after given period of time, right? Because this reaction need to have some time. We are using two reagents basically here. So we have the R1, which is lyse for CRP, and this thing is dissolving red blood cells. We are destroying them, and together with the diluent, this is also preparing the specific buffers for the CRP antibodies and the particles, latex particles, which later will scatter some light, and this light amount of this light which is scattered during or after this reaction will be also, let's say, roughly proportional to the concentration of the CRP. Here we have the real picture of the chamber. Usually this is not seen, this is not visible, because this chamber is the temperature in this chamber is like 37 degrees. So everything here, like a laser, this metal block, chamber itself, those tubes, everything is covered with a foam, which is basically an insulator, and you know it's keeping the temperature stable, right? As you can see, there is like a few ports. From the top, we are adding sample. Analyzer can add lyse and uh, a CRP reagent and also diluent, because there are three ports, and on the bottom we will have the waste, uh, the tube which is removing the waste from the CRP counting bath. QC and calibrator table. So this is another block, and here we will have few slides related or a few slides considering the QC, calibrators, reagents, and all those things. So maybe before we will start, we can make like a 5 minutes break, and in the meantime, if you will have any questions related to the previous slides, just let me know over the WhatsApp chat, and I will try to answer them. And as I said, let's make 5 minutes break at this point. Okay, and we are back. So here on this slide, we have some information about the QC and calibrators. So what we can see, what we can find here, is basically information about the calibrators, um, which will be used on the analyzer. And as I said previously, we register like a few volumes, few different sizes of the calibrators previously. So you can see that the same calibrator can be purchased as one vial, two vials, or three vials. And this is the hematology part. And for CRP part, we only have one calibrator, and actually there is a 6 vial inside, because this CRP reaction is a spline type reaction. It's not linear, so actually we need to have at least 6 levels to make this calibration correct. And during the calibration of the CRP reagent, you will need to run each level of the calibrator minimum 2 times in order to make this calibration. So actually the CRP calibration is time consuming. And later I will try to explain you how often you will need to make this calibration. For the uh, for the for the QC material, we also register like a few volumes, but I'm not sure if all those things are available. On the another slide, we have a different picture, so maybe this will be clearer for you. But for the controls, I know that the control material for CRP, there is 3 vials, 3 levels, and each vial is 1 milliliter. And what you need to keep in mind, that the shelf life is one thing. So basically, it's mean that the vials will be stable within 60 days, 1 year, 120 days, right? So it's mean that when the vial is not open, the material is stable through this whole period, right? Until the expiration date. But when you will open the material, when you will open the vial, the material will be stable only 7 days, 30 days, 14 days, or 30 days, right? So keep in mind that the hematology QC, if you have such a QC, you will need to have let's say 2 boxes for each month. If you will, if you want to have 3-level boxes. So this is what I have in mind. Made 3D, this is the material that we will use, and in the box we have 2 low level, 2 normal, 2 high. Medical, the standard is available in the 2 vials in 1 box, right? And for calibrators, for CRP module, as you can see, there is a 6 different vials. So it's like a level 1, 2, 3, 4, 5, 6, right? And actually on the analyzer, you will have calibrator 1, 2, 3, 4, 5, 6. And CRP control, there are only 3 levels, right? Normal, uh, uh, think it's like normal, sorry, low, normal, high, something like that. I don't remember what are the color codings on the caps, but it says level 1, 2, 3, something like that on the vial. So what I want to say is that for this analyzer, we need to have 2 separate sets of QC and calibrators. One set will be for hematology part, and one set will be for CRP part. Reagents for this analyzer. So diluent, 2 volumes, 20 or 10 liters. Lyse reagent, 2 volumes, 500, 200 milliliters. CRP L, which is lyse, also 2 volumes. And we have 2 volumes of reagent for CRP, as you can see. And there is also Mythic 3 CRP cleaner. This is hypochlorite solution, which is used by the device as a external cleaner. And actually, this hypochlorite should be run on the analyzer every day. Analyzer will actually ask you, do you want to perform this? I think it's calling it soaking. Flash cleaner soaking, something like that. So according to your needs, you can basically place an order for the volumes, which will suit your needs. And if you will contact with the product manager for 3D Finalizer, contact Patricia. She will try to give you the best possible option. And maybe in your case, it will be better to have 20-liter containers instead of 10-liter containers of diluent lyes, or other reagents. It's up to you. You need to make your calculation by yourself. Reported parameters. So those are reported parameters from Mythic 3CRP. And what we are seeing, the total number of white blood cells, lymphocytes, granulocytes, and mid-site cells percentage, and concentration, our absolute number for those. Total number of RBC, hemoglobin concentration, hematocrit, MCV, MCH, MCHC, RDWCV, RDWSD. Right? Those parameters. I hope at least you already know the meaning of those things. If not, this is not a place where we will discuss what are the meanings of those things. This is a basic knowledge about the hematology. So since you are here, you need to make your own research. PLT concentration, MPV, PDW, PCT, PLCR, PLCC. Those are the PLT parameters. And also we have the CRP parameter reported by the analyzer. So, since there is a separate chamber, WBC chamber, RBC chamber, PLT, it's a part of the RBC, and as I said, CRP is a separate one. And on the screen of the analyzer, we can also see some kind of messages. Those will be areas where some kind of flags related to the appearance of the histogram, or maybe to the level of those parameters will appear. So basically, analyzer can, for example, if the MCV value, mean corpuscular volume of the red blood cells, will be smaller than the normal level for a human, it means that we have some small red blood cells present. And actually, this can correlate also to microcytosis, small red blood cells present, right? So analyzer will report you this thing, presumably in the RBC messages or flag area. So this is it. For PLT, analyzer can also show you similar information, alarms, flags, WBC, the same thing, CRP, the same thing. First installation of the analyzer. So when you are receiving the device, inside of the device there are few clips, and those clips need to be removed. So few steps. This is just a view how it sits in the box. So here are the position where you can grab the analyzer with your hands. As I said, it's 32 kilograms if I remember correctly. So you can lift it, but in some cases it's better to take 2 persons. Inside of the analyzer, on this side exactly, we have those clips. So those clips need to be removed. One is on the horizontal, horizontal, and one is keeping the vertical movement of the needle. So the needle will not be damaged during the shipment. So you need to remove this thing. And later you need to take a look if everything is fine in the impedance channel. You need to make sure that there is no loose tube or anything like that in this area. On the back of the analyzer, we have power connector. There is also a sticker here which is saying please remove those binding clips from the inside of the analyzer first, and then connect the power. So we also have the reagent tubes connection and waste connection. So according to the colors, we have diluent lyes for hematology, waste connection, and there will be 2 sensors connected also on the back. So this need to be connected before you will turn on the analyzer. Inside of the analyzer, we need to place the CRP reagents. So this is actually the refrigerator for CRP, and this is actually the lice for CRP. So it's sitting on board in this on this side underneath those doors. Those doors are on the left side of the device. So when we will connect all reagents, then we can turn on the analyzer and just wait, because analyzer need to have like a 2 or 3 minutes to turn on itself and then the login window will appear. So for the first login, we have two approaches. We can use the administrator password, which will be admin, or we can use the service account. So as a login, you can type service with a first capital letter, and the password is dm_sir0620. So this is the password for the analyzer. And it's up to you what you want to do. I will recommend to use this second account because it will give you some additional options which can be set for the customer during the installation. So we will log in, and when since all reagents are connected, device will go through the fluidic initialization process and it will prime all reagents. And after this process, the device is running the background check on the reagent, right? So it's making like a startup process. In case that fluidic or startup process fail, so analyzer will give you an error that the background fail. What you need to do, it's good to make fluidic initialization. Just go to the comprehensive device maintenance. It's in the service menu, and make fluidic initialization. Let's say 2 times, because this is also priming reagent. Is removing some air bubbles. Is preparing your device for the future use. And since analyzer is new, you just remove it from the box. It's possible that still some air bubbles are trapped in the tubes, and you need to make some additional fluidic initialization in order to recover the device from the shutdown, from the for from the state. So this is it. But in most of the cases, when everything is connected, I mean all the tubes, all reagents are connected, a device should make initialization by itself. The first one should be done automatically. But just in case, you can use this option. So as a next thing, device will show you that reagents are not replaced or reagents are, let's say, empty. So it's mean that basically there is no information about the reagents. So you need to use a card from your reagent at this point to set up everything on the analyzer, right? So we are taking the card. We are choosing, let's say, diluent. We are choosing it from this list and pressing on setup, right? Pressing on setup, and then additional window will appear here, and it will set, please place the diluent reagent card on the reader, and you just need to place the card there and just wait a few seconds. Information will be read from the card, and then I believe what you need to type is lot number of the reagent. This is the only thing, because the volume, the stability, all those things are on the reagent card, but the lot number of the reagent is not there. So I believe this need to be typed manually. And the same approach should be done for other cards. Okay. What else we can see here? We have something like purchase reminders to the customer, or some kind of, maybe not purchase reminders, but maybe some additional reminders to the customers that reagents will soon be empty. So if you will set those reminders, for example, you will set diluent to 5 liters. When the volume of the diluent will be at 5 liters, the customer will be reminded by the analyzer that diluent is almost depleted. So this is some additional information. It can be useful, but it's up to you if you want to use it. If you will set everything to 0, this will not be active. Background checking. So here is a part, this is the picture from the user manual, and it's saying what is the accepted background limit on the analyzer during the background measurement. And this is if analyzer will exceed one of those parameters, actually analyzer will give you a background error message. Background is out of range. After startup, so if this is the first startup, it's also recommended to make the Mythic 3CRP cleaner soak. So what you need to do is take this hypochlorite solution and just put it to the sampling needle. Of course, this is like automatic process. So you press here, analyzer is showing you additional message on the screen, and then you need to aspirate. The analyzer will aspirate this hypochlorite solution, and this will be distributed through the system, and it will clean the system. So this is it. Please remember to make the cleanser soak during the first installation. There is also an information about the refrigerator for the reagent for the CRP. What you can do is make sure that this part is cold and this part is basically hot, right? There is a Peltier module, right? One side is cold, one side is hot. There is also a fan here and the filter underneath. So the air filter should be periodically cleaned. So you just need to blow out the dust from the filter. But during the first installation, it's also a good idea to make sure that this is warm, not hot but warm, and this is cold. Right? Checking the version of the software, and I'm not sure right now if we have the latest software available on the website. I think it's not available, but it's also a good practice to check with our website what is the latest software version, and just update the software version during the first installation or during the maintenance. Software updates, usually they are fixing some potential bugs or changing functionality of the software or adding some more functionality, so it's good to make those updates. Another menu, this is voltage and current. What will be important here? We need to check the hemoglobin blank voltage, this thing, and also we need to check what is the scattering blank voltage, those two things. And later, if the hemoglobin blank voltage is a little bit too high or a little bit too low, we can have a situation that analyzer will give us an error message that hemoglobin blank voltage is too high or too low, and in that case they will be need to set the gains or current value for this sensor manually, right? And this is the range in which the sensor should be set. And the same thing is for CRP scattering black voltage. In most of the cases, you will not need to make any adjustments here in this menu. But from my experience, I have like a one analyzer where I need to make this adjustment because the voltage was too small, basically. So it was out of range, and analyzer just given an error in that case. So here is also information for the CRP scattering black voltage. So range also specified here. Another thing which should be checked, but is not necessary to adjust it, only if needed, you need to see what is the sampling needle position in the rinsing head, or we call it swap. During the normal operation, basically the end of the sample probe, the tip of it should be at the bottom of the swap or rinsing head. So basically, if you see that it's in the middle or is extending, right, it's going out just a little bit from here, you will need to make this adjustment, and this is the menu which allows you to do that, right? There is like a start, analyzer will make an initialization, and then you can use up and down to go up and down. And what you need to do is to align the tip of the sampling needle with the end or the bottom of the rinsing head, right? That is also okay, and cancel this process, right? Okay, saving, cancel is canceling this whole process, and check is just for checking. So analyzer is just adjusting the position, and this allows you to check this thing. By the way, this procedure will be needed when you will replace the sampling needle, but during the installation, it's just a recommendation to see if this is correct, and uh, and just set it if needed. What we need to do next, background. Check the background of the analyzer. So let's make 3 measurements. Um, and if everything is fine, you don't need to do anything else. But if you see that some parameters are elevated, it's mostly the reason for that is because maybe your analyzer is not primed correctly yet. Maybe it need to have another fluidic initialization. Or what you can do, also try to make complete soak one more time and make another fluidic initialization, and then recheck it. What is the next important process? Here, actually, we already start the calibration process, and we are starting. We can start also with the CRP calibration. So the gain calibration for CRP, or the whole calibration for CRP, should be start here. And this is actually checking what is the background level in the CRP. So we are using the blank uh, background sample or blank sample, and we just need to make 1, 2, 3, 4, 5, 6 measurements. So basically, when you are in this menu, you just need to press the aspiration button 6 times. Just it will take them, I don't know, 5 or 10 minutes, and then analyzer will tell you if the test was passed or failed. If the test was failed, it means that maybe the chamber is dirty, or maybe the CRP line is still not primed correctly with the CRP reagent. So you just need to check those 2 possibilities. But when the test is passed, you just need to save it, and right now the device will have a new reference level for the background. Uh, what else can be a possibility for this thing? The CRP blank voltage. Maybe it's too high, maybe it's too low. So it's worth to see what is the CRP blank voltage. The next step, if we decided to start with the CRP calibration, is to perform this calibration. So as I said, this is 6-point calibration, and this is the calibration curve. As you can see, it's not linear. It's a spline type. So we have a calibrator 1, and in the box we also have a calibrator 1. So for calibrator 1, you need to put a target, and as I said, you need to repeat each measurement minimum 2 times. Right? You can do this even 6 times if you like, but in my opinion, 2 times it's a good number. It should give you correct calibration. And this step should be done for each level, right? 6 calibration, and then this calculate button will be active. So you need to Press it, and analyzer will calculate new or make new calibration curve. And calibration curve, this is that button which is showing you the previous one or the new one if you want to see it. Recalibrate is basically a button which is erasing the previous data, right? Recalibrate. So please make sure that you are not using it when you don't want to delete the data, right? Calculate is a button which allows you to basically make a new calibration curve, and later you need to press on save. This process is time consuming, as I said. So I think the whole calibration will be like a 40 minutes, something like that, maybe half an hour. And this is the calibration for the hematology calibrators. So actually for each calibrator, you can download the data from our website. The same thing can be done for, just a second, I will try to show you that. Okay, here we have a website. So we need to go to hematology, analyzers. Now we need to choose the Mythic 3CRP. Let's go down. What we want to have, the 3CRP calibrators and CRP calibrators. So here we have some documents like an instruction of use. So this can be downloaded by everyone, and also the assay sheets can be downloaded by everyone. So let's download those. And here you have the targets for the calibrator. And the yeah, here's lot, expiration, all those things, right? So here you have the targets for hematology calibrator. There is also some previous lots information on the website. So you got the point. Let's go to the controls. For CRP calibrator, the same thing. New lot or previous lot. There is no previous lots, but this is new lot. And here we have 6 targets, right? Calibrator 1, 2, 3, 4, 5, 6. And this basically is the information that we need to put into all those fields. For the hematology calibrator, this is the information that we need to put into those fields. So what you need to keep in mind is the units that are used by you, where you can make a mistake on the hemoglobin. If you use the grams per liter, this will be 135 instead of 13.5, right? So the error can be done here. So keep in mind this thing. For the concentration of the white blood cells, red blood cells, MCV PLT, it doesn't matter if this is to power 9 or power 3, because this number will be the same. CRP calibrators and controls. This is for later on. This is the control for CRP, and here, and control. So from the assay sheet, we need to put the targets, we need to put the lot number and expiration date, and then we need to make at least 5 repeats. After 5 repeats, this mean and CV value will appear, and then the new calibration coefficients will be calculated accordingly. So the calibration is let's say, automatic, but you need to basically prepare the calibrator according to the instruction of use and mix it and present it to the sampling needle and just press aspiration button on the front panel of the analyzer and make this 5 times, 6 times is up to you. But the minimum number, just keep in mind to make it minimum 5 times. And later we can save it. Okay, there is also a recommendation to get 10 valid counting results. Will and then base it on all. Okay, select at least 5 groups of data. Yeah, so as I said, 5 groups, which will give you the best possible calibration CV value. And the out of range CV does not influence the display. Okay, click save. Yeah, so this is the last step to make sure that you will save the new coefficients. Quality control. So in the quality control menu, we have settings, right? So this is the first window where you need to go in order to set up a new targets and ranges for your QC analysis. So QC settings, and then you need to press on new. And this window will actually appear. So what you can do, since this is for hematology, we can choose from QC mode, whole blood, CBC, 3diff, but also we can also choose the CRP mode, and in the CRP only the CRP parameter will be present here. So this is the first action, to choose what kind of QC mode we want to run, and then you can press import. So this is, I believe, very useful thing. And if you have QR code, QR barcode reader connected to the analyzer, we can go to the website one more time and go to PDF, and you can scan those QRs, those things. You can scan those codes, and actually this is the information which go back presentation. This is that information basically, and in this information we have basically information about the mm, about the concentration of each parameter. I mean target and limit of each parameter, and also there is information about the lot, expiration date, or everything. But if the QR code is not available, what you can do is download those files, QCS. And actually, if you will put those QCS into the root folder of the USB drive and later go, let's go back to the, not this one, to the presentation, take a look here, you have an option file. So if you have those data on the USB drive and you will choose file, another window will appear which allows you to choose the file, and actually the data can be also imported from the USB drive in such a way. Right? It's quite easy, quite simple, but I believe the barcode reader option, if you have barcode reader, is the best, the fastest way. And as you can see, the data was filled. And also analyzer is setting those data, and then you need to save this thing. Oh, it's also shown here, right? SD and the file from the file, the same thing. And when we will set up the QC, what you need to do is set up the QC for each level, right? So let's say that in the previous step we only set up the QC for low level. You also need to set up the normal, the high level, and also need to set up the CRP, right? So so keep in mind that you need to make few files. And when you will set up everything, then you can go to the QC analysis, and this is actually a menu which allows you to run QC analysis. And from the file number, you just need to choose which file you want to use. And let's say that this is your first installation. So you will have 3 levels for hematology and 3 levels for CRP reagents or CRP modules. So you will have 6 files, not 16 like in this case. So when you are here and you will choose the correct level, you just need to prepare your QC sample and present it to the sampling needle and press aspiration button when you are in this menu. And analyzer will start the QC analysis. Later, the result will appear on this screen, and we also have an option to see the QC graphs. So by default, those will be LJ graphs, and QC table is also visible. So it's a table view or LJ graphs, as you can see here on the screen. Here is a slide which is telling you about the possibility of deleting the QC files or cleaning the QC results. If we will go back, click here. Here we have an option to delete and clean. So if you will set up some kind of files here, you can delete the whole file by pressing delete, and cleaning is just cleaning the analysis results uh, for given QC file, right? So I hope you get the point. When the clean can be useful, especially when you are setting up something manually, you are not relying on the QR code or files, and you are setting something manually, and you will type the wrong reference, wrong target or range, and you will see that during the analysis parameter is out of range. You are not able to edit the file when there are some results in the file. So what you need to do first, clear the results, and then you can press on edit and edit those parameters. So this is it. I hope you get the point. So let's go back. Yeah, and I believe it's explained here in the same way. Repeatability test. So repeatability test can tell you a lot of things related, a lot of things about the analyzer. And we also recommend to perform this test during the first installation of the analyzer. Okay, here we have a few slides about the settings. So let's go through them really fast. So time, date, um, I believe this is pretty straightforward, but as you can see, there is basically that menu which allows you to set those things. Input settings, soft keyboard. Device has a touch panel, but actually, if you don't want to use this touch panel and don't want to use, I mean, the keyboard, which will be on-screen keyboard, you can disable this thing, right? So it says soft keyboard can be on or off. So if you will disable it and you will connect the external USB keyboard, the external one will be only used. So this is it. Settings for print. In this menu, we can also install the printer. So you're seeing check automatically. If we will connect the USB printer to the analyzer, analyzer will basically find this printer, and on this list, the printer will be installed. And what you can do is you can also put some kind of report typo. You can choose a type, you can choose a template, and actually this analyzer will give you an option to modify your own um, templates, right? So according to your needs, you can export and import printout templates and modify them, add some kind of logos, add some kind of top margin, bottom margin. Is up to you what you want to do. Auto print settings, so I believe this is pretty straightforward. And also you can specify what kind of data will be printed or not by the printer. Laboratory information or hospital information. So this is the information. I mean, this is additional um, information which need to be or should be filled during the installation of the analyzer. User management. The basic access level is an admin. So we always recommend to make user accounts with which are the common users, not the administrators, but it's up to you how you want to proceed with that. Auto maintenance. So here's the basically those are the settings for automatic processes. So it's like an auto sleep, auto cleanser soak, CRP reagent tube, auto clean waiting. So it's just information how often the auto cleaning of the CRP tube will be done by the analyzer, even when the device is yeah every 24 hours. Let's say this is the and here you have the standard settings for that. You can modify them, of course. Parameter settings. The menu of the analyzer give you a lot of options to specify. This is specify a lot of parameters related to the sample. Uh, I don't know if this is useful or not, but you have this option and you can modify them and use them as like it. Adding new item, as you can see, this will be more useful. Parameter unit. So as you can see, we have a few options here. We also have some pre-specified set of units, but if you like, we can also I think there is a custom. Yeah, there is a custom, so you can also change some of those settings by yourself. Reference ranges. So this is also another thing which can be modified by the end user. And what we recommend is to estimate the laboratory or the end user need to estimate their own reference ranges according to their own database. So this is something which should be done by the end user or laboratory. Adding a new reference group, there is such an option. Flag settings. So this is just a window which is um, uh, is this is just a window which is displaying the specific flags when the number of white blood cells, for example, is lower than 2.5 thousand per microliters, right? And we are saying leukocytopenia, leukocytosis when we are higher than 18,000, right? So high number of white blood cells, low number of white blood cells, sorry. And the same is for lymphocytes, for mid-sized cells, granulocytes, for red blood cells, as I said, macrocytosis, big red blood cells, microcytosis, small red blood cells, and this is basically standard set of flags which are set on the analyzer. And actually, if you like, you can also add some new or edit some of those parameters according to your needs. Host network settings. So this is those settings are for LIS connection, right? And LIS communication settings. Here you have it. So we have some kind of IP address of the LIS server, some communication settings, ACK, right? Acknowledgement. And we also can specify what will be the graphical format of the histograms, which will be sent by the analyzer, or pictures. Okay, this is another segment. And before we will start with that, let's make another short break, 5 minutes, something like that, and then we will continue. Okay, let's continue our presentation. So as I said, this will be a hydraulic circuit. In the analyzer itself, you will find two types of the valves. There will be small and big valve, right? Small and big type, and each of this is a two-way and one-way. Sorry, two-way and three-way valves. As you can see, two-way valves large, two-way valves small, and there is also a liquid pump and air pumps. Air pump is quite small actually. The liquid pump is a standard diaphragm pump, which is used by many manufacturers. It's not only for hematology, right? So you may know this from biochemistry or from a different hematology device, right? This thing is also thing in a different device. Other components: sample probe, swab, pressure chambers, or one pressure chamber basically, counting chamber. There is also CRP chamber on the front of the analyzer. So this is the chamber where the measurement is done and when the dilution is done. But actually on the front there is also reagent heating chamber for this exact part of the circuit, and actually this will warm up the lye solution and the CRP reagent, and the diluent for this analysis is also warm up but in a different heating chamber. Syringes assembly. So you will find two of those assemblies on the front of the analyzer. We have this thing. This is underneath the front panel, and this will be on the left side of the device. Okay. And on this is the diagram, right, for the analysis. So maybe we can make some overview. Let's talk about the basic functions. So first thing, I will personally start with the impedance channel, and later we will talk about the CRP channel, because you can separate those two things into separate components. So impedance channel, what we are seeing, WBC chamber and RBC chamber. Of course, this diagram is not the greatest quality, but in the service manual you will find a better printout. We are seeing also negative pressure chamber, and this is positive pressure for air bubbles and all those things. Right? Waste, diluent, and lice. Right? Those R1, R2 we will not cover those things right now because those are the components. I mean the reagents for CRP. Here is that diluent heater, and here we have few syringes, right? So this one is for diluent, 10 milliliters, and this one is for lice. Right, as you can see, the lice circuit actually for hematology is very simple. We have bottle, we are going in, and this is the reagent or bubble detector. Sorry, bubble sensor. So this is back panel, bubble sensor, one valve, three-way syringe, and then we are going to WBC chamber. And that's it. This is whole lice circuit. Very simple. Diluent, temperature sensor, and also there is a diluent detector. And we are splitting into two circuits. This is the CRP diluent syringe. So right now we will not talk about this part, but let's go to the hematology part. So another Y, and we also have this valve here. So it's supplying diluent to this part of the circuit, and actually this is used for aperture rinsing. And we have this part of the circuit, three-way valve, diluent syringe, and then we are splitting between heater for WBC analysis and RBC chamber. Right? So basically this part of the circuit is supplying diluent between WBC and RBC chamber. So this is quite simple. Another valve in a way of this line was this one. And this is supplying diluent to the sampling syringe, as you can see. Sampling syringe, 100 microliters. And the sampling syringe has a bottom port and top port. The reason for that is because this whole volume should be completely filled with the diluent, and only small metallic piston will change the internal volume of this thing, and this will also allows us to aspirate those 20 microliters of blood from sample, and later aspirate a little bit more from WBC chamber and transfer it to the RBC chamber. Right? So this is it. This complete line should be filled completely with the diluent. We don't want to have any air bubbles, any air pockets here. So this is the reason why this thing is made in such a way. Another thing which is important here is analyzer also need to rinse the inside of the sampling needle. And since this volume of this syringe is very small, it's just 100 microliters, the volume of the diluent here will not be sufficient to rinse this whole volume, internal volume of the sampling needle. So this is the reason why we have this port here, because analyzer can use the pressure of 10 milliliter syringe to rinse the internal of the sampling needle. We also have this valve 3, and you can see that this is directly connected to the rinsing head. So through this part of the circuit, we also supplying diluent to the rinsing head, because we also want to clean the outside surface of the sampling needle right after blood was aspirated or blood was transferred from here to here, right? Because if we will put the sampling needle into the sampling tube, there will be a lot of blood on the outside. So this needs to be clean. Okay, so I believe this part of the circuit is pretty, it's explained, diluent and lyse. I hope it's clear. If not, just let me know over the WhatsApp chat. I will try to answer the question. What we are seeing here, one more time, WBC chamber, RBC chamber. Impedance channel WBC, RBC channel WBC, RBC channel impedance, right? On the WBC, we also have the bracket, which consists the hemoglobin measurement channel. So it will be the green LED and the detector with the filter across the chamber. So it's measuring the absorbance there. What analyzer is needing in order to make measurements to perform everything automatically? We need to have a way to supply diluent and lyse, diluent to the RBC, right? We also need to have a way to remove those liquids from the chamber. So bottom port and this three-way insulation chamber is here because of that. We are removing basically liquid through this port, through this insulation chamber, and this is waste circuit through this valve, and through the pump into the waste. The same thing is happening on the RBC. Bottom port, this part, this part, this part. Pump and waste container. Other part here, the top part, is when you will trace the connections, it's going here. So it's supplying the same function, and it's going here, positive pressure. So this is a tank which is storing a little bit of positive pressure, since this pump is making this positive pressure. And this tank is used to generate air bubbles during the mixing process in the chamber. So in order to mix everything, device will push some air bubbles through this port, through the bottom of the chamber, and everything will be mixed inside, because there is no way, no other way, no mixer, no mechanical mixer, nothing in the analyzer which can mix blood in the chamber. So we rely on the air bubbles. And actually air bubbles is well-established way to mix the whole volume. Basically all manufacturers of the hematology analyzer, they use air bubbles to mix the blood. This is quite common way. um, oh, my colleague is asking why we have a heater on the WBC. So heater on the WBC is supplying warm diluent for the WBC analysis. And actually with some chemicals, with some reagents, you need to have higher temperature in the WBC chamber to correctly lyse the red blood cells. And lyse is not warmed up, but the volume of lyse is just a few hundred microliters. I think it's like 300, 200 microliters of lyse is added to the chamber during the measurement. And amount of diluent is like a half a milliliter or even more. So if diluent is warm and the volume of lyse is smaller, it means that the temperature in the chamber will be higher. So the reaction will be correct. So this is the reason for having heater on the WBC. It's not necessary for RBC because we are not destroying red blood cells. So reagents have some temperature range in which they are working. So this is the reason why we have a heater. Okay, so we are removing liquid and we are adding air bubbles. You may ask, what is the insulation chamber? So actually this whole thing, on some previous pictures, you may see that it's sitting in a metal can. So it's insulated from the outside from electromagnetic interference or electric interference, which are on the outside with a metal can. And actually we also need to insulate the liquid, which is inside, from the outside. And this is the reason for insulation chamber. There is an air separation here. So bottom part, top part is not touching bottom part, right? There is simply just tube and air separation. It's 2-3 centimeters of separation here. So this is separating the liquid, which is inside, from the outside surface. So one electrode is inside, second electrode is on the outside, right? So this is actually how it's working. Electrical separation in the chamber. What else we are seeing? There is like a strange thing here, right? We're supplying diluent by this valve, and there is like a three-way connection going from the outside, and then we are going to the second, and then we are going back, and we are going to the negative pressure chamber. And actually, this is part of the impedance channel and also part of the rinsing circuit for the aperture. When you want to make a measurement, simply you just need to open this valve, and when we have negative pressure here, the liquid from here and also from this port will be drawn into this negative pressure chamber, right? So actually the device will use this valve, this chamber, and those kind of connections to take liquid from here, pass it through the aperture, and make the measurements, right? This is quite simple. And this part of the circuit is connected to the diluent because we need to have a way to prime this part of the circuit. You don't want to have air on this side of the circuit. You want to prime this whole thing with a diluent, because you want to have diluent on one side of the aperture and also on the other side of the aperture. If you remember how the diagram or the split view of the aperture looks like, there was like those two connection, and this was the port for the vacuum basically. So this is it. This is also the part of the rinsing circuit for the aperture. This is quite simple. I hope at least. What we are seeing here, negative pressure sensor, negative pressure chamber, and we having some kind of filters, some kind of Y connection, and the valves, and negative pressure sensor. Of course, the negative pressure in this chamber is made by this pump, and also the sensor is controlling what is the level of this negative pressure. It should be on some stable and correct level. For some reasons, for example, when device need to make back flashing or clean the apertures in reverse, we need to have positive pressure here. So in order to do that, we have this part of the circuit and this valve, and this can be open and actually equalize the pressure here. And then we can open the connection between positive and negative. This valve will be closed and negative chamber, and this will push some air through this thing, and later it will make the back flash of the aperture. So this is how it's done in this way, in a reverse order basically. This is the reason why we have this connection here. This part of the circuit is similar. There is a pump, there are some filters because we are drawing some air into the pump, so potentially some kind of dust can clog the pump, the same reason as here. There are some connection, couplings, reducers, Y connection, positive pressure sensor, and the chamber itself. And as I already mentioned, air bubbles can be supplied here to mix everything. During the rinsing of the outside surface of the sampling needle, we also need to make negative pressure. So this is the reason for this part of the circuit, right? Negative pressure, pump. This is it. Everything is going to the waste, right? It's removed to the waste. So I believe that at this point we are pretty much clear with this part of the circuit. I try to explain everything. So let's go to the CRP part of the circuit. So we have CRP reagent and lyse, and also the diluent will be used to dilute the sample in the CRP chamber. So those three reagents will be considered right now. Also, we have some bubble sensors and some additional bubble sensors. I think this is maybe some kind of error on the diagram or something, but for sure we have a bubble sensors for CRP, for diluent, and also for lyse. For everything there are 4 sensors. Let's take this R2 first, or maybe no, R1 first. R1, and we are seeing that we have this 2.5 milliliter syringe, right? So we can aspirate liquid into the syringe, and later the liquid can be dispensed into the CRP chamber. And as you can see in the way, there is also a heating assembly. The same thing will be on the diluent line for the CRP chamber, right? Because the CRP reaction is at 37 degrees. So we need to warm up the CRP chamber and also the reagents which will go into the chamber. So this part of the circuit is quite simple. R2 is a little bit more complicated, but the line is going like so through the detector and it's connected to this valve. So actually, if we will use this syringe and aspirate liquid through this part, like into this line. Later, we can also push this liquid into the chamber with one line basically and one valve. So this syringe, let's say, is universal between both CRP reagents. One thing is used to basically push liquid inside. The next thing is CRP diluent syringe. So it splits like here, one valve, 2.5 milliliter diluent syringe. Heating assembly is going through the heating assembly, and it's also going into the CRP assembly here. I mean CRP chamber basically. You may notice that there is no air bubble supply. Um, and yeah, this is true because if I remember correctly, analyzer is mixing everything with a diluent syringe. I think it's going up and down a few times. So, and when the blood is dispensed, also the lyse and the CRP reagents, they are already there. So when the blood is dispensed and the diluent is added, everything is well mixed. And this whole reaction is not that important. I mean um, the mixing is not that important in this case. But as I mentioned, this thing will be mixed with a CRP diluent syringe by up and down movement. One more thing which can surprise you is also since we use the latex particles in the latex particles in the as a CRP reagent, analyzer also need to have a way to mix those latex particles periodically uh, in the bottle. So actually it will simply just use the up and down movement of this syringe, and this will push and pull some liquid through those tubes up and down few times, and this will basically mix the whole volume of the bottle correctly, and there is no risk of any sedimentation of those latex particles to the bottom. So this is it. This is how it's done. To remove the liquid from here, this is pretty straightforward. We're just going through few of those valves and waste, and here we go. Later, of course, after the measurements and before the measurements, there are few preparation steps or cleaning steps. So those chambers are rinsed. So analyzer is just adding diluent through this line. It's adding uh, yeah, through this line and removing later, right? To rinse this thing, to prepare this thing for the analysis. Later, the sample is added, and process starts. The same thing happens in the WBC and RBC, just to make sure that there will be no carryover from the previous analysis. So there is a before and after cleaning steps, and actually step by step. I believe this is also explained in the service manual. Yeah. And this is just how the whole measurements is done. So as you know, the volume of blood which is aspirated is 20 microliters, and 10 microliters of this blood is going into the CRP measurement, and 10 microliter is going to the WBC, RBC, PLT measurement. And here we seeing what kind of reagents are added into this chamber. And I think I already explained that. So here we have the chamber view. This is video, so let's take a look on it. And this is basically the dilution process in the chamber. Sorry, I need to be in the presentation. So blood was aspirated. Is it running? Yeah, now it's running. Blood was aspirated, and as you can see, the rinsing head is above the CRP right now, is going down into the CRP, is dispensing like a 10 microliters, and now it's going to the WBC. It's mixing. It's still outside cleaning. The liquid was removed. Now it's mixing with the diluent. Now it's going down. It's aspirating volume. Is going down to the RBC, and in the meantime, analyzer already add the lyse and mix everything. So lysing process happens here, and we have second dilution here, and the reaction for CRP is also happening at the same time here in the chamber. So now it's a period where analyzer is counting. This is end of the counting. This is some kind of rinsing. Right? An analyzer will add some fresh diluent into the chamber to prepare it for next analysis. Okay, let's watch it one more time. And the second video was actually just the hematology part running. You may notice that there was no CRP measurement. So this is just the order of operation for each analysis. As you can see, it's just dosing, mixing, measuring, cleaning, and waste discharge. And those diagrams, I think this is from the service manual or from kind of service presentations which we have, and this is just information how everything is done. But I think it's not necessary to just go through all those things because we already explained this thing. RBC PLT, the same thing: dosing, mixing, measuring, cleaning, and waste discharge. Right, the same thing, but it's shown for the RBC channel. Some cleaning, CRP, dosing, mixing, measuring, cleaning, waste discharge, right? The same thing, but only the CRP part is basically active in this case. Yeah, and the cleaning, waste discharge. Okay, next part of the presentation is about the hardware. So how everything is connected. Main control panel or CPU board as we call it. So there are reagent testing panels, so those are reagent detectors, reagent sealing panels. I'm not sure about this. LCD interface, indicators, buzzers, LEDs, all those things. CRP laser driver panel. This is module for CRP. Reagent refrigeration panel. So this is also for CRP. And other external connections like a valve pump, motor sensors, USB, Ethernets, all those things which are on the back of the unit. So here we have the CPU board. Um, Here on the top of the impedance channel preamplifier, there will be also a metal can, right? Because we are, as I said many times already, we are dealing with a very low voltages. So we want to insulate this circuit from the outside interference. So there will be metal can. Here we have a section which is supplying power to the motors, pumps, valves. Stepper motor drivers are here also. So it's basically like a mechanical part. Let's say this is controlling the mechanical part of the analyzer. There is also a digital circuit. So FPGA unit, application processor, where the Linux operating system is sitting. It's basically here, I believe. And other digital components, some USB, LAN, Ethernet ports, those things are here. External interfaces. So here we will have a connection for the position sensors, for LEDs, switches, all those things. Hemoglobin sensor, it's this one. And CRP signal is also coming to this part of the section, and high voltage multiplying circuit mode. This analyzer is actually using high voltage pulses to clean the aperture. Any debris which can be potentially stuck in the aperture or counting head area will be destroyed or burned by the high voltage pulses. Right before each analysis, actually, there is a few second burst of high voltage just to remove this from the circuit. So there will be few indicators. I never find anything useful about those indicators. So basically, this is just the information. Uh, Voltages, some kind of information if the ARM processor, FPGA, or MPU is working fine or not. The power supply is on the top of the instrument, and it's supplying all those voltage rails to the CPU board. Reagent detection board. So there is an additional board which is located on the top of the instrument, and there is a negative pressure signal, positive pressure signal, and reagent testing signal. So this is most likely what is I think I know what is this thing. This is maybe information from the sensors, from the connectors which are on the back of the analyzer. So floater sensor, I believe. Detection signal output, pressure signal output, collecting. Oh, yeah. So no, this is something else. But two pressure sensors, positive, negative. Sorry, negative, positive. This is the order. And photocoupler signals collecting modules interface. So those are the reagent detection signals from the reagent detector. So those are the photocouplers, right? So optical principle is analyzer is checking if there is a liquid in line or there is a air in line in the tubes, basically. Indicator board. So this is located on the front panel of the analyzer, and there is a the buzzer and also a few LEDs, and those LEDs can change the color according to the status of the instrument. CRP laser driver panel. So this is nothing special. It's just supplying constant current, constant voltage, I believe, to the laser unit, and just controlling the parameters of the power which is going to the laser unit. Reagent refrigeration panel. So this is this part of the circuit is let's say standalone. It's actually working even when the other part of the unit is not active. So we have the power source, 12 volts. I think this is something like separate rail just for that. And this is standalone unit and is controlling the peltiers, is controlling the micro switches and temperature, fan, all those things. So the temperature will be in the correct level. And here we have some additional pictures for that. Maintenance and troubleshooting. Oh. The frequency and the scope of the maintenance are specified in the user manual. You can find there step by step. Troubleshooting is described in the service manual. Don't hesitate to use it. Okay, so this is like a quite good information because this is end of the presentation at this point. So maybe we can also make 5 minutes break and then we will go to the service and user manual and we'll talk about the maintenance. And right after that, I will also try to turn on the analyzer and maybe I can show you few of those options on the device itself. As we as we mentioned previously, right now we will talk a little bit about the maintenance. So the frequency is divided in daily, weekly, monthly, every 3 months or so. As we can see, some daily, weekly, those are the maintenance which should be done by the end user. So it's simple as cleaning the outside surface of the analyzer, execute cleanser soak, and turn off the analyzer. And of course, you need to run the quality control test. Um, Weekly, you also need to clean the outside surface of the sample probe. Clean the outside surface of the counting bat shield case outer box. So what is that? Let's go to this page. So it's mean to clean, like especially in those areas on the top, because there will be some a little bit of some salts potentially. So those things need to be cleaned. Monthly, clean the diluent float sensor and waste float sensor. For the diluent, I believe it's not that important, but for the waste, since this part of the circuit is dealing with the waste, it's good to take a look on it if everything is fine and just wash it with some kind of deionized water just to make sure that it will work fine. Clean the swab every 3 months, clean the inner wall of CRP bath, clean the upper surface of the counting bath shield case inner box. So, swab, rinsing head. Especially underneath, you will see some dry reagents and maybe some blood residues, so this need to be cleaned. Clean the inner walls of the CRP tube, so you will take some kind of swab, cotton swab, and just gently clean the inside with deionized water. Usually, if we will have something, it will be on the top of the CRP bath. Clean the upper surface of the counting bath shield case inner box. So it's the same thing as uh, that's here. It's the same. Every 6 months, we recommend to make analyzer calibration, and in this case, we recommend to calibrate hematology part and CRP part every 6 months. Check and adjust the hemoglobin voltage to 4.5 volts. Annual, you need to look if needed. It's good to check valve 5, 15, 16, and 18. There is no 111 valves there. Cleaning the titanium tubes of the counting pads. It may be necessary, but not always. I will say that this is necessary when analyzer was not used for a long period of time and someone left the reagents inside. Clean the counting pads. So the same thing. If someone left the reagent and device was not used, then you need to perform that. And actually in the service manual, this is step-by-step instruction how to perform all those activities. And here we have some lists of the components. And service manual, as you can see, contains a lot of data, a lot of pictures, information, so it's very useful if you want to troubleshoot any kind of errors. There is also explanation for those things, and also in one place we have problem and possible cause and solution, how to proceed with those things. So I recommend to take a look on the service manual, just read it, and potentially this will give you full information how to proceed with the errors that can appear on this analyzer. And right now, as I said, we will go to the device, and on the device I will try to show you the functions and actually how to use it. Okay, so we have a camera view of the screen. So this will be the first screen, right? In order to log in, we need to type the password. And after a few seconds, configuration will be loaded. And this is actually what you will see. You will see this window. Of course, analyzer usually is making fluidic initialization and later is making background check. So this is what we are seeing. We are seeing background check here on the screen. And since we are here, let's talk about the modes and what kind of options we have on the top here. So when you will press on mode, you can choose what kind of analysis will be performed as the next one. So we can choose venous blood, capillary, whole blood, and pre-diluted mode. And also we can choose between CBC plus 3D, CRP only, or CBC, 3D, and CRP. Right, combo of mix of those two previous ones. So we are in the venous blood. So in order to aspirate blood, there is an aspiration button on the front, and right now you're seeing analyzer saying analyzing sample number 10 because this was specified previously. When we will press here, device will give us some additional options. And what we have here is we can type right now the patient information. But for the sample which is underneath, and actually the sample which is processed by the device currently, if we want to type those information before sample will be run, there is a pre-entry button. And I can show you also this thing. We need to wait a few more seconds because analyzer is not done with the analysis. Okay, and you can see pre-entry is valid, and the same thing. We can simply just put patient's information before analysis happen, and patient info is the same thing, but after the analysis is done. So it's up to you what will be your approach in this case. The buttons like validate, print, I think this is pretty straightforward. Patient's info, we already talk about those things. And here we have some additional information since we are on the service account. This thing is not visible for normal user. Custom parameters. Here you have some additional information which you can put or add to the patient's information. So it will be blood type, PSR, reticulocytes. It's up to you. And those data will be also printed. Microscopic examination parameters. So if your standard procedure is to make microscopic examination and check the smear, you can also type those data here, and this will be printed on the printouts. What we have here is edit results. So basically you can also manually edit results if needed. This is available for service, this is available for administrator, but it's available for common user. So this is the reason why I told you that common user is an account that is recommended, not the administrator or service. Delete is simply just deleting the results. The result which was done previously and it's on the screen. What we see here, common. So this is actually button which is allowing us to send the data to the LIS, but right now the LIS connection is not established, So this is the reason why the button is not active. We are saying also previous and next. So this button allows us to go through the sample archive and just see the result. So this was the sample analysis. Review is basically our archive. And as a first thing, we are seeing the table view, right? So the data is in a slightly different form. Right, as you can see. What we can see here and what we can do here. We can print the data, delete, export as a CSV file to the USB drive. We can edit, we can put the patient's info, or we can query some additional, or we can look into the archive and find the results which we needed. We also have a graph, and this is a graph. This is a detailed view of the sample, right? So there is also microscopic examination parameters, custom parameters, run chart. We can press on run chart. And actually, right now, we can do something like that. And the run chart is making those charts. LJ graphs basically are done in this way, but for sample, so we can use it, this thing, we can use this thing for to see how the precision looks like on the device. And also CV give us similar thing. We can check what is the CV, right, for each parameter. So this is something like repeatability tests. And special info is that thing. This is that thing. Okay, and maybe we can go to query. And as you can see, we can try to find the result in the database according to sample ID, first name, last name, medicine record number, or something like that, right? Or just try to find it according to specific range of dates or something like that. QC, this menu allows us to run the QC analysis, and I already make few runs. So if we will go to the first file, this is the hematology part. So you can see we have all the parameters for hematology. This was the low level. This will be the normal level. This will be the high level. And we also have 4, 5, 6. This will be only for CRP. And actually, on the beginning, I have a problem with the CRP calibration. So I need to perform the calibration on this device before we start this training. As you can see, it was running low, and after calibration is well inside middle of the range, basically. So we have QC graph, QC table. So this is it. This is basically the same data, but it's shown as a table. Here we have graph, and here we have QC analysis. So this is the last results for given level, as you can see. Now we will switch to CRP, right? And QC settings. Here we are setting up our files. I mean, yeah, files. You could call it files, I believe. Reagent management. So as I said in my presentation, when you will turn on the analyzer, you will need to go here, choose the reagent, and simply go to setup, use the RFID card. I think I have one here somewhere on the back. Yeah. Use the RFID card and activate your reagents in this way. For each reagent, there will be separate cards, so you need to activate each reagent separately. When we will go to home, Oh, okay. So right now we have a short break because by mistake, I press on the replace button, right? Replace diluent. So analyzer is replacing diluent. On the top, we also have replace all, just in case we want to replace all reagents at the same time. Usually when you are replacing the consumption of reagent is not equal. Uh, so uh, so there will be no time, n- not necessary to replace all reagents at the same time. And usually you will replace diluent, lyes, or CRP reagents separately. Each one will be replaced separately. And maybe underneath, you can also see information about the reagents. So it's saying that in the bottle of lyes, we should have 75 milliliters and 25 milliliters in CRPR. And the residue volume right now for those two is 0 and 0. And I think I didn't set them during the installation. So this is the reason why I'm seeing the 0 and 0. But for diluent and for lyes, we already have some kind of values. And yeah, this is what you will see usually in this menu. Okay, operation is completed. Let's go back. So this will be the main menu. Those uh, four things on the top are available also from the tabs here. This is add diluent. So if you want to make the pre-diluted sample, you can also dispense diluent from the sampling needle into the appendor or some additional or some extra external sample tube. Here we have the calibration menu, and in calibration we have one thing, which is the CRP gain calibration. This is that menu which I was showing you before, and in order to make this calibration you just need to make 6 blanks measurement, and then if the conclusion is passed you need to save it, and this will be new reference, and then you can go to calibration. And as you can see, we have 6 levels of calibration, the calibrators. It's a spline type reaction, so targets for each concentration, and according to this thing we have the calibration curve calculated by the analyzer. Next calibration is this one, calibration. So this is the whole blood or hematology calibration. So we are choosing whole blood, we are putting the lot number here, expiration of course, and we need to specify the target. Later we need to run measurements, right? 5 times minimum, even 6 on the list. And then we need to choose those repeats and just save it. So this is calibration. Manual actually allows you to change the calibration coefficient manually. And since we are logging as a service, we have additional set of calibration factors. And actually those which are here are factory set calibration, right? So this is it. And this is user available calibration. So if when we are logging as a service, we are changing the factory calibration. So if we will go to manual, we will not change anything here, but those values will change. But if we are logging as an administrator, basically those things will be modified because this is not visible for administrator. Setup, date and time, input setting, laboratory information, agent setting, reagent parameters, auto maintenance. So this was already shown on my presentation. Data, parameter units, this was also shown there. Gain settings, this was not shown. I mean, it was shown, but this is that window, right? Hemoglobin blank voltage and CRP scatter current value, right? Sorry, not voltage, but value. So this is that window which allows us to change those two parameters and adjust. You see, I'm changing here, so this is also changing in the real time because the LED is active in the hemoglobin channel. It's active in the hemoglobin channel, so I'm changing that. Same thing can be done right here, I believe. Okay, let's go to 29 or 28. Flags, so this is just a menu which is about the flags and host communication. This is the menu which allows you to set the IP address of this device, and LIS is allows you to set the IP address of the LIS system in the network. Debug settings, so this is just available for the service user. I think will not be useful for engineers. Language settings, we can change the language here. So there is a few languages available, as you can see, and more translations are available or possible, I should say. You just need to let us know if you need to have any specific translation. And of course, we can try to help you to make those. Auxiliary settings. So there is a bunch of settings which can be useful, like a show results edit flag, you know, flags for high and low levels, as you can see. So nothing special. Printer settings. So as I said, this can this is a menu where we can install the printer when we have the automatic check usually in the printer list here. If you use the USB printer, the printer will appears on the screen, and then you can just specify what kind of settings you want to use. User, here's a menu where we can make some new users. Thermal printer settings, this is just information, settings for the built-in printer. Patient's information, oh, this is a menu which allows us to choose what will be shown. Uh, let's say remarks, successfully save it. And when we will go here and patient's info, oh, this was the background. Patient's info. Remarks, right now disappear on the screen and previously was not present here. So this is it. Oh. So patient's info, this is it. Service. In the service, we can replace reagent, we can clean the analyzer, right? In the maintenance, we have like a cleanser, so unclog, uh, and do other stuff, right? So this, I think this is pretty straightforward. fluidic initialization. So this can be useful during the first installation of the analyzer. Prepare for shift. So this is also useful when you plan to shut down the analyzer for a few weeks. I recommend to prepare it for shipment because the whole process will rinse the analyzer with deionized water and remove the residue of the reagents. This will be better for the reagent. And here we have some syringe self-test, as you can see, pressure, other self-test. What can be useful is RFID reader test. So we can actually, it's not a test for the reader, it's testing the cards. And right now I use the same card, and as you can see, this is card for lice type expiration. It was not used before, so it's a new one. Production date, all those things. So this can be used to test if the reader is working and if the card is valid or not, just in case. We can also test the WBC, RBC voltages. So it's saying WBC or RBC voltage in normal, so it's not showing you the voltage level. Valve pump, so that's a valve and pumps. That's it. Oh, I just press unlock. In temperatures, analyzer is showing you the temperatures, ambient, CRP reaction back, 29, refrigerator for CRP, diluent 34, right? Diluent temperature, heating temperature. Voltage currents, so sensor, so this is basically real-time reading from the sensors. Counter the number of counts which was performed on this device. Disk info, just free space information. Logs, I think this is pretty straightforward. And calibration, temperature calibration. It can be useful, but I believe there will be no need to make any adjustments here. But this menu allows you to basically adjust the reading from temperature sensor. So ambient temperature calibration or ambient temperature sensor. This sensor, which is built into the analyzer, show you 26.4, and you know that in your room right now is 21, not this thing. So you can type minus 5, right? For example, and analyzer will make this adjustment for you. Gain calibration. This is additional menu, and this menu allows you to set the gains for WBC channel and RBC channel according to some WMCV and MCV parameters or targets, as you can see. So you need to make this measurements, but this will be only useful when, for example, you replace the counting chambers, because on the new counting chambers, there is a possibility that impedance channel is not identical. I mean, maybe the opening in the aperture is slightly different, or maybe part of the electrical circuit in the impedance channel is not identical. Touchscreen calibration. So this is a menu which allows you to calibrate the touch panel. Position adjustment. So this is that up and down position of the rinsing head. Pressure calibration. Please do not change anything here. I don't even know how to use it, actually. I don't know how to use it. No one explained this to us, so they only said do not use it, do not change anything. In the toolbox, one thing which can be useful is this switch mode, and you can change it to exhibition mode. So actually, when the device is in the exhibition mode, device will not use any reagents. It will not prime itself. The fluidic system will not be initialized. And actually, this is for, as the name suggests, for the exhibition. So if you want to show this analyzer to the customers, you can use this analyzer in such a mode, and you don't need to have any reagents connected. But for normal operation, you need to be in the normal mode. So this is toolbox. What else we are seeing? Data cleanup. So this will delete the results from the analyzer. we have a version, so this is the software information, and we have upgrade button. So if we have the upgrade package on the USB drive, and the USB drive is present on in the USB port, this will appear here, and you can make the software update. And screen test is just a testing if the screen is working fine or not. So it's nothing special. Two buttons which are here. One is shutdown and one is logout. Do you want to log out? Yes, no, no. Do you want to shut down, perform the close operation? So we can shut down the analyzer in this way. Okay, and since we don't have any questions at this point, I believe this is end of the presentation for today. And as I said, I believe this is the end of the presentation for Mythic 3 CRP. And tomorrow morning, we will start with the Mythic 18. So basic knowledge about the 3D device will be the same, as I said, because 3D is a 3D. That is the same principle on all analyzers, but M18 is made in a slightly different way. So this is the reason why we need to spend a little bit more information, especially on the fluidic circuit. And we will also go through the software, so you will know how to use this software. So thank you for today, and I already mentioned this on the beginning. If you have any questions about the things that you are seeing on the screen right now, something is not clear, please ask your question over the WhatsApp chat. I will be very, very pleased to answer to your questions. And even right now, if something is not clear, just ask your question over the chat. I will respond to your question today, or maybe tomorrow morning. We will start with a small Q&A session, and I will give you a response in this way. So thank you that you've been with us today, and I hope we will see tomorrow morning. Bye. Have a great afternoon.
We see ourselves as a lifeline which connects doctors, diagnosticians, and patients with cutting-edge IVD technology. We provide medical solutions to make your healthcare better. It all started in 1985 in Poland when Korme had its beginning. Since then we have been striving for a better, healthier world. Next, in 2001, Orphe joined the world providing advanced hematology equipment. In 2005, two brilliant teams became one, like two rays of light focused on one lens. Over the years we have helped more and more people throughout all the world with the access to reliable tests and high-performance IVD technology. We refreshed our brands to emphasize our common goal. We are constantly expanding our portfolio to help you with a wider range of challenges. We help doctors, lab technicians, IVD experts and foremost, patients, to deliver positive health outcome. All of that led us to become one. Korme Diagnostics. The lifeline to better health.